Okay. Next one, side angle side similarity theorem. Okay, so this one is when I have two pairs of sides with the same scale factor, right? We use K for that. Two pairs of sides with the same scale factor and a congruent angle between those sides. That's the key, is that the angle has to be between the sides with the same scale factor. So side, angle, side. So that's like the way to remember it, is because the angle is between the two sides, okay? I should use it when, I don't know what to put here, when I have two sides and one angle. I don't know, seems dumb, but I should use it when I have two sides and one angle. Kind of seems self-explanatory. Okay, so look, here I have, these are vertical. Notice that 5 times 2 is 10 and 6 times 2 is 12, right? So there's an example of side, angle, side, okay? Okay, let's look at 2A. So they have the congruent angle, right? But is 36 over 9 going to be the same scale factor as 37 over 9? No, so these ones are not similar. Because we have to have a congruent angle between sets of sides that have the same scale factor. Is there any questions, you guys, so far? No? Okay. What about this one? I don't see any numbers inside this angle here, but are they congruent? Yeah, because they're vertical angles. Then 10 times 3 is 30 and 9 times 27 is 30, right? So they have the same scale factor and a congruent angle between them. So now the tricky part is going to be how to figure out the order of the angles, right? So angle A is the same as angle A, right? That one's easy. Nope, I said 9 times 3 is 27. Well, maybe I said that. What I meant to say is 10 times 3 is 30 and 9 times 3 is 30, or is 27. Is it U or V next?
I think it's U.
So A goes to B. That's on the 27 side, right? So which corresponds with the 27 side, the 10 or the 9? The 9, so it's V next, and then U. And I'd say by side, angle, side. Okay, on the next one, we're comparing the small triangle to the big triangle, right? So 66 is a side length on the small triangle. Is 11 a side length on the big triangle? No, it's, what is the big triangle length? Yeah, 77. So I need to figure out if 77 divided by 66 is the same thing as 54. No, not 54. What number? Where'd you get 62, Oliver? Good, because I need the whole side for the big triangle. Someone with a calculator do 77 over 66 for me.
1.166 bunches 67.
Okay. And then what about 62 over 54? Is that the same thing?
No.
So, not similar.
Is there a way to see if it's just not similar, like right off the bat, just eyeball and see?
Unless you know your fractions really well.
You're funny.
Yeah. Any questions on side angle side? No? Okay, last one is side, side, side. So this one is when all three sides have the same scale factor. I should use it when I only have side info, no angles. So what you want to do is use our side inequality, triangle side inequality conjecture from day one. So I want to match up the biggest sides, the middle sides, and the smallest side, right? So I need to see if 55 divided by 42, because those are the biggest sides, right? And the middle sides, so 44 divided by 33, and 32 divided by 23, I need to see if those are all the same decimal.
No.
They're not?
No.
You're positive or are you guessing?
No, I did the math.
You typed them?
Yeah.
Okay, so not similar. Because I don't have the same scale factor between the corresponding sides. Does that make sense, guys? Okay. Okay, so let's try another one. Careful on this one. I'm going to do 50 divided by 30, right? Because that's a side on the bigger triangle and a side on the littler one. And then what do I divide 70 by? Nope. Here's 70, 42. And then careful on this one. This one's tricky. What do I divide 55 by? 33. Good, you guys, because 22 is not a side on the little triangle, right? Because they did 55 minus 22. So Tyler, look, 55 is the whole big triangle, right? And 22 is this. That's not a side on the big or the little triangle, right? So to get the rest, they did 55 minus 22. Okay, yeah, Gavin.
You have to make sure all three sides are like the same decimal, because when you'd be able to tell if it's all similar just from two of them.
Well, honestly though, because no, for this you have to tell all three, because maybe on, especially on ones that aren't connected, two of them could be the same and then the third one's off. So you have to be careful.
Well, it's similar.
On this one, it's similar? Okay, so then I'd say triangle. Okay, what letter matches with K? Okay, good. And then what angle matches with L? C goes next. And then D. And then by, side, side, side. Yeah. Questions on side, side, side? Do you guys have any questions? Okay, so here's what I'm going to give you guys, like, probably, I don't know, 10 minutes to work on. Is I'm not going to tell you which one to use. So you're going to decide which of the triangles on the next page are similar and by what, okay? So first, I'm just going to give you a hint on the first one. Okay, based on the information you have, which of the three shortcuts should you probably try? There we go, good. So you're going to go through all 6 of those and decide which are similar and by what property if they're similar. If they're not similar, you don't have to say by what property, just say not similar, okay? Does that make sense, you guys? Okay, you've got about 10 minutes to work on that, and then we'll go over the answers. Good job.